Pythagoras Theorem, one of the most important equation in the world. If anybody asks you what is Pythagoras Theorem, you should begin with a right angle triangle, which means a triangle whose one angle is 90 degree. The side opposite to right angle, that is the longest side, is called hypotenuse, and the other two sides are called the legs. Let's say the length of the legs being x and y, and the length of the hypotenuse being z. I'm going to build a square out of this base, something like this. I'm going to call it x into x. Now I'm going to build another square out of this side length y. It would be y into y. So you can say the area of this green square is x square and the area of this blue square is y square. Now I'm going to build another square out of this hypotenuse, which would be something like z by z, which is z square. Now Pythagoras theorem states that in a right angle triangle, the sum of the square of legs is equal to the square of hypotenuse, which you can say x square plus y square equals z square. Stating Pythagoras theorem is one thing and proving is another thing. So now we'll try to prove that why this statement is true. Let's say I'm going to build a square whose side is x plus y, which means I have built each side with the help of two lengths. One is x and the other is y, yellow being x and green being y. I'm going to connect this point to this point and this point to this point, which I'll break this whole square into these four regions. The complete square has side x plus y, so you can say that the area of this square is x plus y into x plus y, which is x plus y whole square. Now, when you are looking into these four regions, you clearly see that these two are squares and these two are equal rectangles. If anybody asks you what is the area of this square, you are going to say x into x, which is x square, and the area of this square is going to be y into y, which is y square. If you look into this rectangle, the breadth being y, the length being x, so the area is going to be xy. Similarly, length being x, breadth being y, the area is going to be xy. So the complete area is x plus y whole square, which has been fragmented into x square, xy, xy, which will help you say that x plus y whole square equals x square plus y square plus 2xy, which you have already studied in your algebra class. Now we are going to take a relook into this square. I'm going to interchange this green side with this yellow side, and I'm going to interchange this yellow side with this green side, and it would be something like this. The yellow has been shifted to the right and the green has been shifted to the left. The yellow has been pulled down and the green has been pulled up. What you notice, we just rearranged green and yellow. Other than that, we didn't do anything. So the shape of the figure remained unchanged. The area of the figure remained unchanged. So if anybody asks you what's the area of this square, you are going to say x plus y whole square, which is equal to x square plus y square plus 2xy. Now what you're going to do, you're going to connect this point with this point, this point with this point, this point with this point, this point with this point. Now what we did, we have divided this complete big square into 5 portions, something like this. So you have 4 right triangles and 1 quadrilateral, which we are going to prove that this is going to be a square. Now if you look into these 4 right triangles, you see the legs being x and y, and the angle containing between x and y is 90 degree. So you can say that all the 4 triangles are congruent, which means they are same. And the hypotenuse of these 4 triangles is defining a quadrilateral. So you can say the hypotenuse of all the congruent right triangles would be equal. So the quadrilateral which you see is definitely going to be a rhombus. But if you look into a right angle triangle, the other 2 angles other than 90 degree, these 2 angles are complementary angles. So if I call this angle as A and this angle as B, so A plus B is going to be 90 degree. So if this is A, so this is also going to be B, because these 2 triangles are congruent. So this is A, this is B. So A plus B is 90 degree, and this is the angle which is being contained by the quadrilateral or the rhombus. Now you see this is a straight line and the angle in a straight line is 180 degree. So A plus B plus 90 will definitely make it a 180 degree. So we can say this rhombus has each angle as 90 degrees. So we can say definitely this rhombus is nothing but a square. Now if you look into the area of each congruent triangle, you see the base and height as x and y. So you can say the area is going to be half xy, and the area of this square is going to be z square. It would look something like this. So you can say the complete square has been divided into 5 regions, and each region can be added up: half xy, half xy, half xy, half xy, that is 4 times half xy, that is 2xy plus z square. So we can say x plus y whole square equals x square plus y square plus 2xy, which is also equal to z square plus 4 times half xy, and 4 times half xy is nothing but 2xy. This 2xy and this 2xy can cancel each other, and you would be left with x square plus y square is equal to z square, and that is what you have proved your Pythagoras theorem. So if anybody asks you how you're going to prove it, you're going to prove it through this amazing visual technique. There are other ways also to prove Pythagoras theorem. Can you find other ways to prove it?